students. Good evening, students. Good evening, students, everybody. Yeah, students, good evening, everybody, my dear students. I hope so you're all doing well. Thank you very much for presenting, students. Before started me, many students were came. I'm very happy for that. Arindal, thank you very much. Students, before going to start, Unacademy is giving a nice chance for the students. Academy is giving a nice chance. There is an analysis to learn the different subjects. Unacademy is giving a free platform for the students to learn all the subjects. So kindly students, to get this benefit, subscribe and enable the bell icon. So students, today I am going to start electrostatics. Before starting the electrostatics, over here I want to tell about the Unacademy platform. Is giving a nice chance for the students for a less cost, for an unlimited access. 12 months plan, for a 12 months plan, as well as 6 months plan. For a, you can trial based plan, monthly plan. So students, you can take a monthly plan if you are having any doubt, and can have access with all the teachers, your favorite teachers as well as non-favorite teachers. So this is the monthly plan, but before to get this benefit with a 10% discount, kindly use my referral code Kishore Live. Use my referral code Kishore Live and definitely you can get this chance. Okay students. Okay then, let me start the concept of electrostatics. Today we are going to learn the electrostatics part. Generally electrostatics students used to feel tough, but I want to give students the most important concepts I want to discuss over here. Instead of discussing everything, since you are going to write for the exam point of view, I want to give you students that the most important concepts we will discuss. So the most important concepts before discussing, so let me explain the basic concept. Let me explain the basic concept over here. First, Coulomb's law. If you consider, just briefly I'll explain students. Coulomb's law. Yeah, okay students. Coulomb's law. When two charges are separated distance, briefly, students, briefly, don't feel bored. I'm going to discuss the most killing concepts plus problems. So when two charges are separated distance, there is an interaction between the two charges takes place. Due to the interaction between the two charges, force experiences. The force is directly proportional to product of two charges and inversely proportional to square of the distance between them. When you remove this proportional, we need to write a constant, that is 1 by 4 pi epsilon naught q1 q2 by r square. This is in free space. In between the two charges, if free space is there. If medium is present, 1 by 4 pi epsilon naught k q1 q2 by r square. If medium is present, 1 by 4 pi epsilon naught k q1 q2 by r square. Suppose if some part is medium and some part is free space. Anyway, I am going to discuss, students. Please behold or hear that. If some part is medium, some part is free space. Two charges q1 and q2. Separation between the two charges is r. So some part is having a length t, a dielectric constant k, and remaining part is free space. Generally, students, when force between the two charges is there in free space, straight away you will write 1 by 4 pi epsilon naught q1 q2 by r square. Now when medium is present over here, force with medium, when completely medium, if it is there, 1 by 4 pi epsilon naught k q1 q2 by r square. Now whenever some part is free space, some part is medium, so please write down the effective distance over here. So after writing the effective distance, that is r minus t is anyhow free space, as it is we will write, plus this length t root k times r minus t plus t root k. So why we should write like this? If we consider the basic mathematics, I am going to use over here for understanding purpose. See here, students, when two charges q1 and q2, when completely medium is there, completely medium with the dielectrics constant k, then force with medium will get that here 1 by 4 pi epsilon naught k q1 q2 by r square. So whenever free space is there, students, whenever free space is there, same distance it is there, of course, but free space is there. If I say, of course, d is equal to r, then when I remove the dielectric constant, obviously force is increases by k times. Force is increases by k times, but I want to get same force. So if I want to get the same force, what I have to do, students? I need to increase the separation. Suppose if I increase the separation, the gradually force is decreases. Force is inversely proportional to distance square. When r is increases, force decreases, and at a particular instant, the force will be balanced with medium and with free space. Suppose at this instant, force with medium and force with free space is both are same. If I say, so what can I mention, students, over here? That 1 by 4 pi epsilon naught q1 q2 upon d dash square. So now, students, as I told you, simple mathematics, you need to equate. So when I equated over here force with medium and force with free space, both are same. So this is, you will get over here that 1 by 4 pi epsilon naught k q1 q2 by r square. Here 1 by 4 pi epsilon naught. Students, what do you mean by epsilon naught? First of all, it is a permittivity. Generally, permittivity of free space, it is also called inverse degree of permission. Inverse degree of permission. See, electrostatic force depends on the medium. Since electrostatic force depends on the medium, so depends on the medium, the value of epsilon value will be changes. In medium, the force is reduces by k times, so it does not allow to interact. So that is the reason we will mention over here that 1 by 4 pi epsilon q1 q2 upon d dash square. So these two gets cancelled over here. The remaining term, if you consider over here, that 1 by 4 pi epsilon gets cancelled as usual. 1 by kr square is equal 1 by d dash square. So finally d dash square is equal to kr square. Then d dash is nothing but r root k. So that is the reason when you remove the medium over here, you need to increase the separation as r root k times. You have to increase the separation. So that's the reason I have used previously directly d minus t plus t root k. You can see over here. See here, students. Here t root k. So r minus t plus t root k. Suppose if multiple slabs are there, if I say, students, if multiple slabs are there, then how to analyze? If we consider, let us suppose q1 charge, and then Q2 charge. Separation between the two charges is D. If one slab is having a thickness D1 and its electric constant is K1, and another slab is having length T2 and K2, and so on. So only 2 is there. If I say D minus, this part is free space, D minus of T1 plus T2 plus T1 root K1 plus T2 root K2. If 3 are there, minus of T1 plus T2 plus T3, T1 root K1, T2 root K2 plus T3 root K3, and so on. So this is the way to write, students. Now, as you know that concept of field, so this is about your concept of force. If multiple charges are there, then the net force is equal individual forces. You need to go for add. See, this is called the superposition principle, we will say. Since force is a vector quantity, we need to add vectorially. Add vectorially. So when you are adding vectorially, let us suppose I'll take one example over here that 3 charges are placed on an equilateral triangle Q, side A. Then I want to find the net force. All are having same sign of charges, students. Then I want to find the net force on this charge. So force between these two charges is repulsive force. Between these two charges also repulsive force. Here angle is 60 and here also 60. Here force developed is F1 and here force developed is F2. Then the net force is equal to root of. What is F1 and F2, students? Both are same only. 1 by 4 pi epsilon naught Q square by S square. So F1 and F2 both are same. That is equal to F I am writing F square plus 2F square cos 60. Value of cos 60 is 1 by 2. Then we'll get over here that net force is equal to root 3 times F, we can say. Okay, students. So this is about the idea of force I am giving you, students. Now suppose if I give idea of electric field, if we consider. So concept of field or electric field, the space or region in which its influence can experiences. The space or region in which its influence can experiences. This region is called field region, you can say. When two charges are separated distance, there is an interaction takes place, but there is no direct contact between the two charges, but still experiences a force. Still experience a force means that something is present. So that something is called field. But in the exam point of view, you should not say that something is known as field. So the space or region in which its influence can experiences. The space or region in which its influence can experiences. If I bring any charge over here, so this charge experiences a force, if I say, then this charge is in the field region. If this charge is over here, it does not experience any force. This charge is not in a field region. So mathematically, if we consider that electric field intensity is equal force per unit positive test charge, which charge we are placing that particular charge, it should be very small, students. Test charge should be very small. So the electric field intensity is equal to force per unit positive test charge. So unit of electric field intensity is newtons per coulomb. Unit of electric field intensity is newtons per coulomb. So if we consider that two charges are Q and Q naught, here charge source charge is plus Q, and at this point the charge is experiencing a force. Then the force between the two charges, we can mention over here that 1 by 4 pi epsilon naught Q naught by R square. When I bring the charge over here Q naught, force per unit positive test charge, it experiences electric force. So that is 1 by 4 pi epsilon naught Q by R square. So this is, students, electric field due to a point charge, we can say inversely proportional to R square. Students, we will discuss some numerical sums, then we will continue with dipole due to the field. This is electric field due to the point charge, of course. Now just a minute, students. Yeah. Okay, students. Then a charged rod, now continuous charge distribution. So for a continuous charge distribution, if we consider, how to find for a point charge, as I told you, electric field due to a point charge is 1 by 4 pi epsilon naught Q by R square. In the case of continuous charge distribution, a charged rod of fixed length having a charge density lambda Then the electric field intensity over here, that see, for a continuously infinite density, infinite charge is there, that is also I'll take that. This proof is not required since you are going to write the test. So electric field intensity due to a continuous charge distribution, lambda by 4 pi epsilon naught r into q1 q2, of course lambda by 4 pi epsilon naught r into sin theta 1 plus sin theta 2. So when it is a point charge is there, of course charges we need to mention. So electric field intensity due to a finite length, if we consider having along x component as well as y component. So along x-axis lambda by 4 pi epsilon naught r sin theta 1 plus sin theta 2. Along y-axis if we consider cos theta 1 minus cos theta 2. Suppose students, if it is infinite, theta 1 and theta 2 must be equal to 90. So the reason, if we consider, what is the reason? See here that for an infinite rod, let us suppose if I say this is an infinite rod, if I say, so the final end if we consider, at an angle with respect to this reference line 90 degrees. And the bottommost point also you have to bend completely down. So that the electric field intensity due to this infinite rod, if we consider for an infinite, if I mention theta 1 and theta 2 must be equal to 90. So if theta 1 and theta 2 is equal to infinite, if I write over here that sin 90 anyhow 1 plus 1 2. So then the electric field for an infinite rod lambda by 2 pi epsilon naught r. This is only along x-axis. Similarly along y component, if you say cos 90 is 0. So electric field along y-axis is 0, we can say. So for a semi-infinite, if we consider one end is in our hand and another end is at infinite. So theta 2 will be 90 and theta 1 is equal to 0. So sin 90 is 1, sin 0 is 0. So we'll get over here that electric field intensity will be lambda by 4 pi epsilon naught r naught. Similarly along y-axis, if we consider over here, electric field will be, if we consider 1 by 4 lambda by 4 pi epsilon naught r naught, we can say over here. So somebody is asking me, can you tell me which formula, students? Somebody is asking me which formula, the previous one or this is one, lambda by 4 pi epsilon naught r naught, lambda by 4 pi epsilon r naught. Why? Because cos 90 is 0, cos 0 is 1 anyhow. So theta 1 is equal 0, theta 2 is equal 90. If I substitute, we'll get over here that lambda by 4 pi epsilon r along x-axis plus y-axis. See, if you students, the direction is very important over here. This is along x-axis parallelly away or perpendicularly away. Along y-axis parallelly away and along x-axis perpendicularly away. Suppose you see, students, over here. So this is a rod if we consider and I want to find at this point. So parallelly away, if I say upward direction, perpendicularly away along this direction. Based on this one numerical sum, I choose, students. Let me explain this point. So definitely I will do, students. So semicircular ring having a charge density. Students, some students were asking me. So this formula derivation definitely I'll explain, students. Over here, you need to take a small. Just I will tell you overviews how to do. So just generally continuous charge distribution, if we consider, you need to take a small elementary part. Let me take a white page over here. Some students are asking, sir, how it is came. Yeah. Okay, students. See here now. Just I will tell you overview how to consider, how to solve. If anybody want, you can see. Suppose at this point I want to find. Since this is a continuous charge distribution, you need to take a small elementary part. Or here, let us suppose this is R naught, if I say. So this is length L. Small elementary part, students, DL. This is DQ. Lambda is the linear charge density. So lambda is equal to, you can write over here that DQ upon DL. So then DQ is equal to lambda times DL, students. So what is the electric field intensity due to this elementary part? So that is 1 by 4 pi epsilon naught DQ by corresponding this distance, students. R square I will write. Here R is nothing but root of R naught square plus L square. See, this is angle theta if I mention. So later on corresponding, suppose infinite if we consider students, theta upper part is 90 and lower part is also 90, minus 92 plus 90 will say. So tan theta is equal to what you can mention students, L by R naught. So then L is equal to R naught tan theta. So if I differentiate with some quantity, then DL is equal to, so DL is equal to R naught secant square theta d theta. Yes students, yeah, almost it will come students, of course. Then dq is equal to lambda times, in place of dl, r naught secant square theta d theta. Yes students, yeah. Then what about r students? R square is nothing but r naught square plus l square. So can I say over here that in place of l, r naught tan theta, can I simplify students with this? Somebody is asking me students this derivation. So that's the reason I am showing for them, r naught square tan square theta. So r naught square, if I take common, 1 plus tan square theta, this is secant square theta. Yes students, r square value. Yeah, here electric field due to this elementary part having two components, you can say over here. One is x component, another one is y component. This is the electric field. So this is here angle as theta I consider, here also theta. So this is dEx is dE cos theta, and y component students dE sin theta. Is it clear students? So along x-axis as well as along y-axis is there. Now I am providing you electric field due to this small elementary part, so dE I consider. So now in place of dq you can substitute, and in place of r square you can substitute. Now you can go for integrate. You can go for integrate students. Now that integration of dE is equal to 1 by 4 pi epsilon naught, along x-axis I am doing students, dE cos theta, 1 by 4 pi epsilon naught, in place of dq lambda r naught square secant square theta d theta upon, in place of r square r naught square secant square theta, and then cos component is there students into cos theta. Then if you simplify along x-axis, you will get that expression only students. Similarly along y-axis, if you see dy is equal integration of dE sin theta, then you can go for integrate along y-axis. I hope so you understood. Still students, anybody is having query, kindly join with me in an Unacademy special class. Follow my page. Definitely I am going to provide you this proof detailedly once again. Okay students, this is for EAMCET point of view I choose, so that briefly I have explained. I hope so you will understand students. So next over here that, so this is the finite length if you consider that theta 1 to theta 2. So this is the basic formula you can use. So now suppose semi-infinite, as I told you, theta 1 is equal 90, theta 2 is 90, theta 1 is 0. Suppose if you choose students over here that infinite, if I say both are 90 of course. Then suppose you see students here, semicircular ring having charge density lambda. So your electric field due to the semicircular ring lambda by 2 pi epsilon naught r, and along y-axis if we consider students 0. So y component is 0, and along x-axis lambda by 2 pi epsilon naught r. For a quarter circle, if you see students, same funda, parallelly away, perpendicularly away. Like this analysis, if you see lambda by 4 pi epsilon naught r, it comes. So as I told you students just now, infinite line charge, if you see theta 1 and theta 2, if we substitute as 90, we'll get over here that along x component as well as along y component. See over here, now one problem I choose students, after that I'll come to this explanation. Yeah, a long wire with uniform linear charge density lambda is bent into two configurations as shown. So find the electric field intensity at point O. See students, whenever you're solving this kind of problem, please choose like a segments, you can say. This is one segment, second segment, and then third segment. So for a first segment, if you see like this, it is there. As I told you, electric field due to this semi-infinite, of course, parallelly away, perpendicularly away. First segment. Similarly, second segment, if we consider over here that this is the second segment. If I choose now at this point having same distance, of course, r, if I say this is the point in the first case O, and now here O students. So parallelly away means along this direction, and perpendicularly away means along this direction. See students, here E1 and E2, and here also E2 and E1, both are same only. Since both are same only, the net electric field will be cancels along y component as well as x component. So due to the first segment and third segment, electric fields are cancels with each other. Only this particular segment, only the quarter circle is present. For a quarter circle, as already I told you, this expression along x component as well as along y component. So if I mention over here that quarter circle over here, that what will get students over here, that in this case along this direction, and due to this along this direction. So what is the value we can say students over here, that lambda upon 4 pi epsilon naught r naught. Here also lambda by 4 pi epsilon naught r naught we can say over here. So lambda by 4 pi epsilon naught r naught, if I mention over here that students, angle between these two is 90. So the value will be resultant students root 2 times lambda upon 4 pi epsilon naught r naught we can say. So for a first segment, if first question if we consider, this will be the final answer. See students, similarly second question if we consider, anybody can answer students who is in online. Can you tell me students? I am observing over here. Please answer students. If anybody knows, please answer students. Yeah, good evening everybody. Hi, good evening. Actually directly I started. I am very sorry for that. The moment when I opened, I started. Hi everyone, students. Hi everybody. So can you tell me students, anybody answer for this question who are present over here? Yeah, good evening everybody. Students, good evening. Many students are saying hi, good evening sir. Don't mind that. Directly I started the class. Yeah, students, can anybody answer students? Those who are present? No? Those who are watching lively, can you tell me the answer for this question? No problem. Even if it is wrong, I will correct students. No? Okay students, I will explain over here that. So same funda you analyze students. Just let me take over here one new page over here. Yeah. You can see here students. Yeah, good evening, hi, good evening. Please tell me students, anybody, just very simple students, this question. Please you see students, slab 1, slab 2, slab 3 we can say. For a slab 1 if we consider that, yeah, parallelly away, perpendicularly away. This is E1 and this is E2 if I mention, let us suppose. Similarly students, if you see now that along this side, if you see over here that, just for understanding purpose I am writing easily. Yeah. See students, same position. This is slab 1, and second slab if you consider over here that students, due to this perpendicularly away and then parallelly away downward direction. So E1 and then E2. If you observe over here, E1 and E1 gets cancels with each other. So the net electric field will be present which direction students? Downward direction only. So what is the value of electric field students? Lambda by 4 pi epsilon naught r naught is the distance r naught if I say over here. So both are in the same direction. We need to go for add lambda by 2 pi epsilon naught r naught. Okay students. Similarly, for a semicircular if I choose, for a semicircular if I choose over here that, okay students, you can see now. So the direction of electric field will be along this direction we can say over here. So what is the value we can say students? Lambda by 2 pi epsilon naught r naught. So these two will be equal and opposite direction, because due to this semicircular ring, upward direction, due to this part downward direction. So both are having same values. The net field will be cancels with each other, 0. I hope so understood students. Please tell me students if anybody want once again. Students, please tell me if anybody want or here. No? Yeah, good evening everybody. So I hope so everybody understood students. Thank you. Yeah, we'll move on to the next question, next idea students, next analysis concept over here. If you see that over here, yeah. A segment of a charged wire of length L and charge density, if you observe over here, that lambda 2, you can see, students. Segment of a charged wire of length L and infinitely long charged wire of density lambda 1 lie in a plate right angles to each other over here. So lie in a plate right angles to each other. Since right angles to each other over here, if you see that, the diagram I will show you, students. Please see here, students. It's a very nice question, students. It's a very nice question. Please interact with me, students. I am observing over here in a live chat. If any kind of difficulties, if not understand any step, please ask me. I am here to explain you once again, students. Yeah. Suppose two rods are placed over here perpendicular to each other. So it is an infinite rod, if I say over here. Its linear charge density is lambda 1. And another one, students, lambda 2. So this is at a distance R0. And this one is having a length L, of course. Okay, students. Now, if you want to find, yeah, hello, everybody, hello. Okay. So if I want to determine the force of interaction between the two wires, we have to find, students, the force of interaction between the two wires. So you do one thing, students, that you take a small elementary part over here. You take a small elementary part. dq is the elementary part. And at a distance x, I am choosing over here. Distance x I am choosing. So its length is dx, if I say. So what is the value, students? Lambda 2 is equal to dq upon dx. What is the value of dq? We can say, students, lambda 2 times dx. Am I correct, students? Lambda 2 times dx, we can say. Now at this instant, what is the value of electric field? If I ask you, the electric field E is equal, as I told you just now, for an infinite rod, if we consider infinite line charge, lambda 1 is equal to 2 pi epsilon naught x, we can say over here. Then the force is equal electric field intensity E into small elementary part over here dq. So what is the value of force? We can say, students, lambda 1 upon 2 pi epsilon naught x into, yeah, it's also important, students. Sir, explain some important. Yeah, it's very important, students. So definitely I'm going to provide you problems only, students. So dq is nothing but lambda 2 times dx. Is it clear, students? Nani, understood? You asked me, sir, explain some important bits. Yeah, there's a problem solving sessions I'm giving you anyhow. So now you have to go for integrate. So where to where we have to integrate, students? The first element we can consider a distance R0, and the last element we can consider a distance R0 plus L. So R0 to R0 plus L we can integrate. So when you are integrating over here, that which is equal to lambda 1 lambda 2 upon 2 pi epsilon naught into integration of 1 by x dx. From where to where we have to integrate, students? R0 to R0 plus. Yes, students, got clear now? Students, those who are present in online, kindly tell me, students. So give me reply. If you are understanding, okay, I can proceed continuously. So what can I mention, students? Electric force integration of df is total force F. Lambda 1 lambda 2 upon 2 pi epsilon naught. Integration of 1 by x dx will be log x. So log upper limit minus log lower limit, R0 plus L minus log R0. So log R0 plus L by log R0, log A by B, we can say. So this is the force of interaction. Nothing I have done, students. See here once. So these two plates, one is infinite line charge and another one is rod of length L. Both are placed perpendicular to each other. So what is the force of interaction between the two rods we have to find? So for that, what I have chosen over here, that I choose over here at a distance x over here. So at a distance x, I took a small elementary part over here. So for that small elementary part, if you observe over here, that electric field intensity at this point lambda 1 by 2 pi epsilon naught x. Then what will be the force? We can say, students, electric field into dq we can say. So what is the value of electric field? 2 pi epsilon naught x. What about the charge, students, in terms of linear charge density? lambda 2 times dx we can say. So that is I have substituted and then I have done integration. So next question, students. So next question, here that a ring of charge with radius 0.5 meters has 0.002, almost, or it's very small elementary parts, friends, having a gap over here, 0.002 pi meters gap it was there. And then if the ring carries, the total ring carries a charge of +1 coulomb, then the electric field at the center we have to find, students. Since the electric field at the center you need to find over here that, see, if you assume that, if you observe over here that the electric field at the center due to the ring will be 0 when complete part is there, because if you take a small elementary part, due to this the direction of electric field is away, just exactly opposite point if I consider another element, so these two will be cancels with each other. Since these two will be cancels with each other, so this segment and this segment will be net electric force or electric field will be 0. So but if you observe over here that this part is not present over here, it means that what, this end oppositely exactly how much it is there, it will not make cancels with each other. So due to this the direction of electric field is away. So how to find if we consider the electric field is equal 1 by 4 pi epsilon naught, this charge is dq, if I say dq upon this distance over here, radius r square. So now 1 by 4 pi epsilon naught value, students, 9 into 10 to the power of 9. And what about the dq if we consider? So wait a minute, students, I'll take one page over here, then you can analyze over here that the ring is like this, students. Then due to this part, assume that this is a ring. These two will be cancels with each other. These two ends will be cancels with each other. Then here only this part will be present exactly oppositely. How much it is there? Same amount of part it is present over here. So total charge is 1 coulomb for a radius 2 pi r. And small elementary part over here dq, 1 coulomb, dq charge upon corresponding length over here 0.002 pi. So dq we can eliminate, students, with this. After getting dq value over here, then we can say over here that the electric field intensity due to that part 1 by 4 pi epsilon naught dq by radius square. So you can substitute over here 9 into 10 to the power of 9 and then you can eliminate the value. I hope so you can solve, students. Still anybody wants, students? Please give me a replay. So definitely I am ready to explain over here once again, students. So we'll move on to the next question, students. Yeah. So dq value you can eliminate by taking a linear charge density and then you can find. Yeah, very good, Sharmila. Option B, sir. Good. Thank you. It's absolutely correct. Option B. Yeah, we'll move on to the next question, students. A block of mass m. It's very simple, students. Question is very big, but it's very simple. See the work done, whatever the work has done. So that is stored in the form of electric potential energy. Yeah, hi everybody. So whatever the work has done is very good, Amulya, absolutely correct. Whatever the work has done, so that is work done by the electric force should be balanced. So what is elasticity? Since over here negative charge is there, let me take one new page over here, students. So then there is a spring attached with a block of mass m, a spring constant is k, and your negative charge is there. So this is the direction of electric field. Since this is the direction of electric field, the force experiences over here in the opposite direction. So for a negative charge, if you see, for a positive charge, the electric force is in the direction. For a negative charge, if we consider, opposite to the direction. So it will compress. So the work done is equal to force into displacement. So what is the force, students? QE, and displacement is, let us suppose compression is x, if I say QEx. So this must be equal to half kx square. So whatever the work has done, it is stored in the form of a electric potential energy. So that is QEx. So x gets cancelled, then x is equal, we can mention over here that 2 QE by k, we can say. I hope so understood, students. Please, students, by after completion of listening, kindly send me which topic you want. That particular topics definitely I am going to publish in coming days. either in special class or in YouTube, students. Okay, students. Yeah, so we'll get the option as 2 QE by K, we can say. Yeah, another very nice question, students. If anybody knows, kindly answer, students. If anybody knows this option, kindly answer. A uniformly charged and infinitely long line having a linear charge density lambda is placed at a normal distance y. This is the distance y, students. So this is at a center y, if I say. What is this value, students? R. What about this value, students? R. Yes, students. Yeah. Consider a sphere of radius r. So r is greater than y, of course. This length is very small when you compare with this. So electric flux through the surface. What do you mean by flux, students? So the flux is nothing but a group of electric field lines passing in a given area. Students, those who opted, kindly opt, students. If you were having, if you know, Praveen, hi Praveen, Anuj, Vaibhav, Amulya, PP Sharmila, kindly answer. Anybody knows? If you know. So the electric flux through this part we are going to find. So the electric flux, if you see, students, a group of electric field lines passing in a given area. But in this case, students, if you see, the electric flux is equal within this closed surface 1 by epsilon naught times charge enclosed within the option. Yeah, very good, Anuj. Very good, very nice. Option C, absolutely correct, students. 1 by epsilon naught times. I hope so you are enjoying my class. Yes, Vaibhav. Yeah, total potential energy stored in a spring, work done by the electric field. Yes, yes. So somebody kept to answer and then removed, but kindly check, students, once. 1 by epsilon naught times Qn. Yes, yes, Amulya, very good, option C. So let me explain once that 1 by epsilon naught times charge present within this length over here. So how much charge? Its linear charge density is lambda. So what is the length, students, from here to here? Root of r square minus y square. Yes, students, barabar na, students? R square is equal to x square plus y square. So r square minus y square. Similarly, this part is also having, students, root of r square minus y square. So what will be the total length, students, from here to here? So what will be the total length? So we can mention over here that 2 root r square minus y square. So 2 root r square minus y square over here, that since lambda is linear charge density, so can I write over here that lambda is equal to Qn by total length over here 2 root r square minus y square. Then the charge enclosed within the closed surface will be lambda times 2 root r square minus y square, we can say. So this is, if we substitute over here, we will get the electric flux as option C. Yes, students, got clear now? Yeah, students, we'll move on to the next question, students. So determine the electric field strength vector if the potential of this field depends upon x and y coordinates, students. See, first of all, relation between field and potential, students. What is the relation between field and potential? So electric gradient potential, negative of gradient potential is called the electric field. So E is equal to minus dV by dr, you can say, students. So E is equal to minus dV by dx. Negative of gradient potential is called electric field, we can say. So if you differentiate, you will get the electric field. With solution, I am coming in front of you this question. So electric field, since over here, see, students, whenever a more than single variable is there, function as more than single variable. If more than single variable it is there, that, yeah, electric field more than single variable. If you see, students, over here, electric potential is a function of distance. Since electric potential is a function of distance over here, if it is a more than single variable is there, E is equal minus dou V by dou R. If single variable is there, straight away minus dV by dr. So it is a partial differentiation, and this is a differentiation. Gradient potential difference by length gives the electric field. So our V is equal to ED, we can say, students. So E is equal to minus dou V by dou R. So whenever a potential difference is a function of x, y, z, then E is equal to minus dou V by dou R. So along x-axis, if I say minus dou V by dou x, along y-axis minus dou v by dou y, and along z-axis minus dou v upon dou z. Then after finding over here that along x-axis as well as along y-axis, now we can mention over here that E bar is equal to Ex I bar plus Ey j bar plus Ez k bar. Then if the question comes over here magnitude, you need to take magnitude, otherwise as it is you can mention. Students, since you are in electrostatics chapter, gradient electric potential is called electric field. If you are in a magnetic chapter, gradient magnetic potential is a magnetic field. If you are in a gravitation chapter, gradient magnetic field is the magnetic potential. Gradient magnetic potential is the magnetic field, we can say. I hope so you got clear, students. Still any confusion, kindly send me a message. I will move on to the next question, students. This anywhere with the solution I had written differentiation, kindly you can go for cross check later on. Yeah, another important term, students, over here, the self energy. Yeah, we will do one or two some students. After that we will do this concept. Yeah, based on field strength. As I told you over here that potential difference is provided by, potential difference by length is provided by field. Can anybody answer, students, this question? Find the electric field. Can anybody answer, students? Amulya, Sharmila, Vijay, Anuj. Kindly answer, students who are present lively. Yeah. See here that as I told you that potential difference, if you observe, students, over here, the potential difference from here to here, potential difference is 30 minus 15. You can say over here that 15 is a potential difference by its length, students. So what is the length? If we consider over here, this length is how much, students? 10 centimeter. So now between these two, this is M. If I mention over here that, then MB is equal to 10 sine 30 centimeters. I can say, students, 10 sine 30 centimeters. So sine 30 is 1 by 2. We can mention over here that, students, 5 centimeters we can say over here. So here 5 centimeter over here, if you see now that potential difference how much, students? 30 volts by potential difference by length, gradient potential. So 5 centimeter. Yes, students? Sorry, 30 minus 15. Sorry, 30 minus 15 by 5. So what you can mention, students? 15 by 5 centimeter. Meters if you convert over here, because options are given in terms of meter. So minus 2 meters over here. So plus 2 it comes. So 300 volt per meter. Option C, students. Yes, students, got clear? Option C it will come. Yes, students, got clear or not? Kindly tell me, students. Yeah, next question will do. Yeah, option C is absolutely correct. Good, good. Amulya, Nani, very good. Option C, good. Question number, next question. An oil drop of mass carries a charge carried by 1 electron. It is kept in an electric field produced between the two parallel metallic plates, separated by 2 centimeters by applying a potential difference. What potential difference should be applied between the plates to make the drop stationary? Okay, students, I'll take one page for understanding purpose over here that. See here that 2 plates are separated over here. So suppose this is a positive charge is there. And another plate, if we consider, students, so negative plate is there. So the electron is balanced, you can say over here, students. So the separation between these two is D. Concept I am telling, students, then you can simplify over here. Yeah, thank you very much. Amulya, Nani, clear, sir. Everybody. So the potential difference here, electric field exists is E, students. So can I, as I told you, potential difference by length gives the electric field. That is E is equal to V by D. So it is a uniform electric field, of course. Since the direction of electric field is along downward direction, so the electric force at which side, students? Upward direction electric force will be balanced with gravitational force mg. So the electric force will be balanced with mg, you can say. What is electric force, students? Q times of E is equal to mg, we can say over here. So q is nothing but ne, one electron is there. Since q is equal to 1e, e into electric field is equal to mg, we can say. Students, can I mention over here that in place of E, V by D if I substitute. So EV by D is equal to mg, we can say. So whatever the question comes based on this, you can solve, students. So now you can observe, students, to make the drop as stationary, what should be the potential drop difference is the question. So if potential difference is the question, then V is equal to, you can write over here that mg into D upon E, we can say. So can you simplify, students, this question? So mass is given. So the mass is given. Okay, students, one electron is there anyhow, charge of the electron 1.6 into 10 to the power of minus 90, and separation is given 2 centimeters. Yes, students, G value is anyhow 10. Mass, D, and charge. Yes, students, can you simplify, all of you students? So if you simplify, what will get, students? Your option D it will come, I hope so, students. Please cross check, students. Yeah, next question, students. This kind of questions are important over here. Yeah, option D. So n identical small spherical drops of water, each of radius smaller and charged to same potential V, are formed to a bigger drop. So then what is the potential of the bigger drop is the question, students. What is the potential of the bigger drop? So I'll take one new page, students, for concept, and then you can solve the problems, of course. Yeah, option D, Vaibhav, very good. Amulya, very good. Very nice, students. Students, those who done mistake, please don't feel. Sometimes it may be a calculation mistake. Okay, students, no need to delete here. Everybody can understand. Okay, students, yeah. See here, students. If n drops, n droplets, each having a charge q, I am writing, students. So like this, n charges are there. When you are combining the total charge, then q plus and so on n times. So the total charge is equal to nq, we will say, students. Keep aside this. Q is equal to nq, we can say. Keep aside this. And potential due to single drop. Potential due to single drop. So 1 by 4 pi epsilon naught q by r, we can say, students. Potential due to single drop 1 by 4 pi epsilon naught q by r, single drop. Okay, students. So each radius is smaller, I am assuming, students. Each radius is smaller. Suppose if you consider over here that all are combined. So like this n number of charges are combined, then it is equivalent to a bigger droplet of radius r, and its potential is V. The total charge, how much we can say, students? Of course over here that nq is the answer, total charge. So the volume of the smaller droplets n times must be equal to volume of the bigger droplet, I can say, students. Volume of the smaller droplet is equal to volume of the bigger droplet, of course we can say. So n times of volume of the smaller droplet is equal to volume of the bigger droplet, we can say. So n times 4 by 3 pi small r cube is equal to 4 by 3 pi capital R cube. 4 by 3 pi gets cancelled. So what can I mention, students? R cube is equal to n into R cube, we can say. So the value of capital R is that n power 1 by 3 into small r. Yes, students. Now what is the potential of the bigger droplet you require to find? See that total charge q is equal to nq, and this is the radius r. So the potential of the bigger droplet is equal to 1 by 4 pi epsilon naught. Total charge is nq by total radius is r. Of course, you can say the bigger radius is r. So in place of r, n power 1 by 3 into small r, if I substitute over here that, then the potential of the bigger droplet is equal to, we can get over here that 1 by 4 pi epsilon naught into n power 1 minus 1 by 3 into q by r. So 1 by 4 pi epsilon naught q by r is nothing but potential of the smaller droplet into n power 2 by 3. Suppose students, if 8 droplets are combined, simply 8 droplets, each droplet is having 10 volt if I say. So in place of n, 8 if I substitute 2 cube. So 2 cube whole power 2 by 3. So 2 cube, 3 gets cancelled, 4 V we can say. In place of V, 10 volts we can say over here, 40 volts. Is it clear students, everybody? Students, please, students, yeah, Sharmila, absolutely correct. N power 1 by 3 R. Sharmila, it's n power 1 by 3 R. Radius is n power 1 by 3 R. Potential is n power 2 by 3 R. Please correct it. Okay? No problem at all. Small mistake, not an issue. Over here. You take care. Next time you take care. So generally, bigger droplet radius if I ask you, n power 1 by 3 smaller. Potential of the bigger droplet if I say over here that n power 2 by 3 into V we can say. Okay? Yeah, students. So this is the way to solve, students, this question. N power 2 by 3 V. Students, please, if you are having any queries, if you are unable to ask over here, kindly today at 8:15 in Unacademy app, I am having a special class. So kindly join with me at 8:15 to 9:15. So whatever the doubts you are having, you can interact with me. Today's session 15-20 minutes I'll spend with you people interaction, followed by numerical sums. Okay students, yeah, next problem will do, students. So 3 charges plus q are in capital Q are placed at the vertices A, B, C of right angle as shown. As shown, they said, and diagram is not given, students. I'll give you. No problem at all. I'll give you, students. No need to blame anyone. Plus Q, and then plus Q we can say. So this is here and this is here. So what should be the value, students? Root 2 here. As shown in the figure, this will be the figure, students. Please note down over here that what is the value of Q if the net electrostatic energy of the configuration is 0? Yes, friends. Now, up to now, I choose, students, electric Coulomb's law, field to take point charge, field to take continuous charge, and as well as flux also I discussed. Now, coming to the point of potential energy. Students, in 1 hour, I cannot choose all the concepts, but I am trying to make you simplified manner, whatever I am choosing. So, today, 8:15 session, I will continue whatever you want. Yes, students. So what is the charge if we consider, what is the capital Q value? The question is asked that what is the value of capital Q? See students over here that potential energy, if we consider, basic definition is that 1 by 4 pi epsilon naught Q1 Q2 by R is that generally we will write, students. But a group of charges, whenever it is present over here, that you remember that, students, whenever the group of charges when we consider over here, U is equal to 1 by 4 pi epsilon naught is a term you can take common. Please write down, remember, first charge, second charge, capital Q into Q by A. First charge, फिर third charge, plus capital Q into Q root 2A. Yes, students. Next, second with 1 no need to do because already 1 and 2 it is came, students. 2 and 1 reversely not required. So 2 into 3. So that Q into Q by A. So this will be the electric potential. Sorry, electrostatic potential energy. Sorry, students, electrostatic potential energy. Yes, Praveen, very good. Option A is correct. Absolutely correct. So then U is equal to 0. Then you can eliminate, students, capital Q value. If you eliminate, you will get absolutely option E will get. So suppose, students, 3 charges are there. So 3 into 3 minus 1 by 2. 3 terms will get. 1, 2, 3. Suppose if 4 charges are there, if I say, students, how many terms will get, students? 4 into 4 minus 1 by 2 we can say. So 2 are 6 terms will get. Yeah. Option A, very good, students. Very good. Students really are doing well. Praveen, Nani, Vaibhav, Amulya. Good students. Please join with me, students, at 8:15 if possible, students. Okay, students. Now, next question, students. Can anybody answer, students, this question? S1 and S2 are two concentric spheres enclosing charges 2q and 3q respectively. So what is the ratio of electric flux through S1 and S2? You have to find, students. Ratio of electric fluxes through S1 as well as S2. To see here, students, electric flux is nothing but 1 by epsilon naught times charge enclosed within the surface. Suppose here, if you see now, students, flux through S1, if I say, so flux through S1 is equal to 1 by epsilon naught times charge present is 2q. Similarly, flux through S2, if I say, students, 1 by epsilon naught times through S2, if I say, the total charge is present inside 2q plus 3q, students, 5q. Yes, students. So the ratio, if I say over here that 5s1 by 5s2, 1 by epsilon naught gets cancelled, q gets cancelled. We'll get over here that 2 by 5 is the answer. Yes, students. So 2 by 5. Option C is the answer. Yeah, very nice question, students. Yeah, before discussing these are the questions, definitely today I will continue, students, don't mind. The app, actually time is going to be finished. So that is the reason. Self-energy concept, students, which is very important over here that. I'll tell you over here that. What do you mean by self-energy? So the energy required to assemble a differential charges dq by bringing them from where, students? From infinite to assemble a charged ball is the intrinsic energy. Means when you are assembling a charges, how much amount of work is done against the field. So that work done is stored in the form of a self-energy. That work done is stored in the form of a self-energy, you can say. So self-energy of a charged spherical shell, if you see over here that q square by 8 pi epsilon naught r. Self-energy of a uniformly charged sphere, 3q square by 20 pi epsilon naught r. See here, students, this continuation of derivation, I'll explain, students. I'll not skip, students. I will explain you in the app. Okay, students. Over here that self-energy concept formula. Please remember that for a shell it is forming. So one formula I'll give you derivation. Remaining you can do. Suppose at an instant over here that, see, all the charges we are bringing over here on the surface of the shell only. So the totally positive charge will be exist over here with the radius x or with the radius r, if I say. So what is electric potential at this point? At an instant, small charge is there, but I want to bring the total charge is q, if I mention. So for a small charge q, if I say over here that 1 by 4 pi epsilon naught q by r, and dq amount of charge I am adding, if I say, students. So then the work done is equal to potential into charge dq, we can say over here. So v is nothing but, students, 1 by 4 pi epsilon q by r into dq amount. So like this, how much charge we are bringing, students? Initially no charge is there, so no work is required. No charge means no work. Now we are bringing a charge at an instant means against the charge. You have to do against the charge means why? Because there is a field exists. Charge is there means obviously field exists over here. So against this field, some work must be done over here, students. So whatever the work is done, it is stored in the form of a self-energy to assembling charges from infinite to bringing like a shell. So q by 4 pi epsilon r into dq, we can say. So that is integration of 4 pi epsilon r is a constant. Integration of q dq, q square by 2, capital Q, if I substitute, q square by 8 pi epsilon r. So self-energy of a shell, if we consider 1 by 8 pi epsilon naught q square by r, or q square by 8 pi epsilon naught r. So I hope so you understood, students. So I hope so you are very happy with me, students, with my explanation. So thank you one and all who are present since 1 hour. I am very, very happy. Please join for an Unacademy subscription. The charges are very less for a 12 months plan, for a 6 months plan. So these are the charges with 6 months 10,125 rupees. For a 12 months plan, this is the cost. And if you want to go for like a trial based, you can cross check. You can join with 1 month plan with less cost, 2,250 rupees. Please join and get unlimited knowledge with all the teachers. All top educators are present in Unacademy in all the subjects. So you can enrich or you can enhance your knowledge. But please use my referral code as Kishore Live. Please use this referral code and then you'll get 10% of benefit as a discount. And one and all, thank you very much students. Thanks a lot who are watching in online as well as offline students. Thank you one and all my dear students. Once again I am telling you, so please join with me 8:15. My class is there at in Unacademy app. Kindly join 8:15. Kindly join with me students. Whatever the difficulties today's session, you can interact with me. Students, in the next session, which chapters, what are the chapters you are feeling difficult? Please message me. Definitely I'm going to come in front of you. Yeah students, thank you one and all. Bye Amulya. Bye everybody. Bye students. Bye Nani. Bye PP Sharmila. Those who are present, everybody, one and all, thank you very much who are present since 1 hour. Again and again I am telling, thanks a lot. See you at 8:15 p.m. Those who are interested, please join with me. I will take the concepts which you want plus followed by numericals today's session. Okay students, bye students, bye one and all.